Piers, we are very happy to have you here today. Excited to hear a little bit about you. For everyone on the call here, this is Piers Ridyard. He is the CEO of RDX Works, which is the core developer of the Radix protocol. Piers, would you mind giving a bit of an introduction here? Maybe talk a little bit about what brought you into the crypto and DeFi space. And then after that, what brought you to Radix and RDX Works?
Yeah, sure, absolutely. So my background's pretty varied. I actually got into crypto via hardware, which is kind of a strange route. I was building consumer electronic devices and selling them through like Apple and a bunch of other retailers. And one of my friends called me up and was like, "Hey, there's this new cryptocurrency called Ethereum, which is about to launch. We'd really like to start mining. You're the person that we know that has got the most knowledge about like building like electronic stuff." It wasn't really like anything to do with what I was doing already, but it was like, "Can you help?" And I was like, "Okay, cool. What's a cryptocurrency?" And it sort of went from there. And I started mining on the Genesis block of Ethereum and then started going to the meetups and got really interested in sort of like the idea exchanges that were happening in the early days of crypto. Like this is actually the really early days of like the Ethereum smart contracts and stuff like that. Concepts like DAOs, concepts like stable coins, concepts like governance, they're actually really big already. And I just found it incredibly intoxicating. And then like after about a year of playing around in the community and mining, I started going, okay, well, I want to be more serious about this. Let's start thinking about where this could be applied as technology. And so I ended up founding a company called Shawmatics, which built essentially decentralized deal room software for syndicated insurance deals. Because I was like, well, this is a great smart contracts, great way of like managing money flows and contracts between entities and all this kind of stuff. And that went through Y Combinator. And by that point, I'd already met Dan, who was the founder of Radix, and had become utterly fascinated with his technology. And I was like, okay, I can choose to build on any like platform because it's my company. I'm going to start building on Radix. And I just got more and more into the technology that Dan was building. So by the end of Y Combinator, I finished Y Combinator, and then Dan was like, okay, I'm going to buy your company. You're going to come on. You're going to become CEO of Radix, and you're going to help me sort of like turn this. You've got the bug. You've got the vision. You've got the. You understand why Radix is special, but I need you to come and help me sort of make Radix bigger. And so that was my journey from Ethereum mining all the way to becoming CEO of a layer 1 protocol.
So at that point in time, what was the state of Radix, or was Radix in a current state?
Yeah, so Radix had, Radix had been a community project for a really long time. Dan started it in like 2013 as a research project after he'd sort of like spent a bunch of time in the Bitcoin community and sort of come across a bunch of things that he saw. He was like, I don't think Bitcoin's going to be able to do all of the things that I think public ledger technology can do. So that was when the research for Radix started. And he was like, it'll probably take me like 3 months to work this out. It took him a little bit longer than that. And when I met him, he had just he was just putting the finishing touches on the previous consensus algorithm Tempo, and was starting of thinking about scaling up the team. So there's only like 3 people in the company at the time, but it had like over 3,000 Bitcoin donated to the project by sort of the early contributors from the 2013 to 2017. So there was a lot of research that Dan had done himself, locked in like what he calls his coding cave, and there was a lot of work to do to sort of turn that into a company rather than sort of like a one-man research project with some like extra operational support.
So is it fair to say that whenever you came in, it was a research project and your goal has been to productionize it?
Yes. Yeah. It was going from how do you turn a piece of technology into something that actually has product market fit?
Fair. I guess that transitions us pretty nicely into, I guess, what brought you into the space initially was the appeal for DeFi. So could you maybe elaborate a little bit about what is the general market value for DeFi and why should people care about this topic in the first place?
Yeah, so for me, the use case for public ledgers, the thought exercise started as being, what are the properties of a public ledger? what are the things that make that public ledger give it an advantage over it being a private ledger? And then what are the use cases that you can fit into those sort of two properties? And so for a public ledger, the first thing that you need to accept, and this was more controversial back in like sort of 2017, 2018, is that consensus has a cost. Like running a public ledger has a cost, and it is non-trivial, right? It's much cheaper just to put a database, you know, on Google Cloud than it is to run a distributed or decentralized public ledger with multiple replication and consensus ongoing. So there has to be whatever application you choose has to be able to withstand or cope with or be fine with a relatively higher cost of operation per, you know, addition to the database, to the public ledger, than, you know, something that you can just stand up on a private database. And then the second thing was, you need to be able, for a public database to be useful, you want to have business objects in common. This is an abstract way of going, are there things that you can describe on the public ledger that multiple businesses would want to interact with completely independently? The easiest example of this is actually a stable coin, right? So someone creates a stable coin, USDC, and now there are multiple businesses like Aave or Uniswap or all of these other companies that are like, yes, cool, that's a useful object for us to be able to use, and we can pass it between these different businesses that exist on top of the ledger. Now, obviously, DeFi didn't exist then, but what we were looking at was going, like these use cases, relatively high cost of per write, and business objects in common. There's a bunch of things it could be, but finance is one of the biggest ones. And then we started then looking at, well, what does this give you as a result? And if you think about the global financial system as the world's most efficient, the purpose of the global financial system is to the efficient allocation of capital. Like, how do you make sure that money can move easily between opportunities? That is where we see the decentralized finance going. This is the most efficient way of describing a financial system, using these business objects in common, things that like assets and bonds and stocks and whatever that you want to be able to trade, but being able to put them all on a shared piece of global infrastructure that allows you to move capital instantaneously between opportunities, and have multiple people who can build competitive applications that can utilize these underlying assets. And so we were like, okay, well, we think the global financial system is going to be completely and utterly decentralized completely and utterly disrupted by DeFi and crypto. So let's build Radix specifically for this end state. Now, well, a lot of people think that DeFi means, oh, it's, you know, permissionless from the point of view of you can't have compliance, you can't have KYC, you can't have AML, you can have all of those things. Like, it's that the infrastructure itself is decentralized and permissionless in the same way that the internet is. And then the applications you build on it can basically be as wide or as narrow as you want. They can be as permissionful as you want them to be, or as permissionless as you want them to be. And eventually, you know, governments are going to issue currencies which will have controls on them on these public ledgers, because of that's where the capital markets are going to move to. And that's why we think that DeFi is essentially like the future of finance. It isn't just this current playground that we have of like things without AML or without KYC or without compliance. It's how do you move everything to a permissionless platform that allows people to build whatever they want in finance.
Could you maybe speak just a little bit to the value or the advantage of a permissionless system? What is it that makes it advantageous to build in a permissionless environment versus a more permissioned environment, let's say from the developer perspective?
Yeah, so absolutely. It's exactly the same reason that the internet won over private intranets, right? Like in the early days of the internet, people were, even, you know, sort of Bill Gates thought that intranets were going to win out, or big corporate intranets were going to be more successful. The France tried to create their own government internet, the French internet called Telnet. And there was these ideas of, well, you know, you can control that system better, but actually the barrier to entry is higher, right? So if you create a permissionless system, anyone can come and build on top of it. So that's your first thing. Your point of entry is easy. I can't go and build on JP Morgan's proprietary blockchain without going and talking to JP Morgan and going through a lengthy process of contracting, all that kind of stuff. But I can instantaneously deploy on top of a public ledger. That's your first advantage, is your low barrier to entry to be able to build something and deploy it to an audience that is already there. And that's a huge advantage versus private instantiations. Then the second advantage is this ability to be able to interact with other applications that also exist on top of it. So if you look at how DeFi has grown, Uniswap is the backbone of many applications that exist on top of Ethereum. Uniswap is a decentralized exchange, but because the decentralized exchange exists on Uniswap, you can now build other applications, let's say Aave, that can rely on the fact that Uniswap exists, and then be able to do critical functions of its application that it didn't have to build. So example of this in Aave is if I need to liquidate a position, I create a loan and someone deposits some collateral, and that collateral, let's say it's Ethereum, like drops in price, the Aave smart contract can automatically use Uniswap to sell the Ethereum and zero out the position without any entity or any person having to get involved in that. But it's the reliance on the different applications that makes this so powerful. So from a developer's point of view, it's that you have a universe of applications that is available to you, and you don't have to ask anyone's permission to be able to start building against it and servicing customers that exist in that audience.
So would you anticipate that the velocity of development in the future would be higher in a decentralized world?
Again, it's like the velocity of development in finance, 100%, right? Like the decentralized, the decentralized, what we're talking about here is the creation of a platform like the internet that is specifically for building financial applications. That means that you don't have your ability to integrate and therefore accelerate the pace of the things that you can build is so much greater than it would be at the moment in fintech, where like if I want to go and pick anything in fintech, if I want to go and use Stripe, if I want to go and use PayPal, if I want to go and use any of these things as a business, all of the things that I have to do to be able to stitch them together, all of the contracts I have to sign, all that kind of stuff. And that's the leading edge of fintech. If you try and deal with banks, you're talking 3, 6, 9 months. So yes, you are talking about a radical shift in how quick it is to build financial applications. And that feels right now, I think a lot of people the finance sector has not had a huge technology revolution yet. Like fintech is only scratching at the surfaces of it, but really finance is this mammoth industry that actually operates in some relatively old school, inefficient from a technology point of view, ways, partly because of regulation and partly just because of how difficult it is to build these integrations between these different financial institutions. If you get rid of that and start from scratch, yes, the ability to innovate and to create new businesses in this space is massive. And that's why you saw, Uniswap went from, $0 under management to $10-12 billion under management in like 2 years.
It's pretty remarkable.
Incredible. And that was built by like 4 people. So something that's managing $12 billion was built by 4 people and operates fine, right? That kind of efficiency, you just can't get anywhere other than in these kind of systems.
So let's touch on then our next topic here, which is, so we've got this great value proposition. We expect the velocity to increase. What is currently holding us back? What are the problems with DeFi at the moment?
Yeah, I mean, the number one, like as you've put here, the number one problem in DeFi, outside of scalability, most people think scalability is the problem. Scalability didn't stop DeFi going from $1 billion under management to $122 billion under management in 2 years, right? So like people wanted to put capital in, scalability was a pain in the ass, but actually, if you go and talk to the DeFi projects, the number one problem is access to talent. There's only about 20,000 active smart contract and DeFi developers, which is kind of crazy. And the reason for that is how hard it is to actually program decentralized finance, how hard it is to build smart contracts. And the reason for that is that when smart contracts were developed with Solidity and by Ethereum, people didn't really understand what the use cases were going to be used for those smart contracts. So they basically went, all right, we're going to build a general purpose virtual machine. And what programming language are we going to use? Well, we're going to use JavaScript as the basis for this, because JavaScript is the most used programming language in the world. But anyone who programs will go, well, that's kind of an insane choice for, a financial system that's like hypercritical. You probably don't want to start with JavaScript. So as a result of these poor decisions that have turned out to be poor decisions, when you look at what people are building on top of public ledgers, and they're basically dealing with finance and they're dealing with hypercritical systems, building is really difficult. The average developer spends 80 to 90% of their time in smart contract developers spend 80 to 90% of their time on security, not on building functionality, just on making sure the code that they built works properly. And so that has meant that while there's been about 500,000 developers estimated to have tried building like it with some, intention to enter the industry, tried building with Solidity and the EVM, there's only about 20,000 that have actually gone through to the point where they are doing it as their day-to-day job. And that has created this incredible lack of developers. Like one developer at the peak of DeFi, one developer was worth the equivalent of $11.5 million in total value locked for every application, because there was so few developers per amount of capital that was coming into these applications. And so that was that constrained the industry. It stopped people being able to build the functionality they wanted to. And even though these developers were spending 80 to 90% of their time on security and getting audits and all that kind of stuff, there's still been like $3 billion worth. You've put $4 billion worth of hats.
More than it should be.
Right. Much more than it should be. And a lot of people go, oh, the tools aren't mature enough from the point of view of how you like manage your code. But really the programming language and the way that you architect in the first place, the way you're forced to as a result of the decisions that were made with Solidity and the EVM, that's the thing that's wrong. Like that's the root cause of a lot of all of this problems that's gone on. And then, as you've put here, lack of scalability. Like if you want to replace global finance, you're replacing the aggregate of all transactions. You need to be able to service the aggregate of all transactions that are happening in finance, all of them. And so global finance today does maybe 2 to 5 million transactions per second. And like, there aren't any ledgers that do anything close to that. Apart from Radix, I actually don't know anyone who has a roadmap to be able to service that kind of level of throughput. And you have Solana, 65,000 transactions, but it gets even worse than that when you start diving down into it and looking at what the performance of DeFi applications is, right? Like Solana says 65,000 transactions per second, but it can actually only do 273 DeFi exchanges per second. And if
could you elaborate just a little bit what the difference between a DeFi exchange versus a regular transaction might be?
Sure. So in the regular transaction is I send money to you, Blake. So I go, here, give me your wallet address. I'm going to send you some stable coin, right? And I send you the stable coin, and you get the transaction. That's one transaction. And every public ledger benchmarks themselves on transactions per second, right? And they go, we can do 65,000 transactions per second, Solana, or 4,500 transactions per second, Avalanche. The thing is that 95% of activity that happens on top of public ledgers are smart contract interactions, not transactions. So not me sending money to you, but me sending money to a smart contract, or a smart contract talking to another smart contract. So if that's 95% of the activity, that's what you should be benchmarking your performance on. Now, of that 95%, the vast majority of those transactions, or those actions, are decentralized exchange transactions. So a decentralized exchange transaction is, I've got some USDC, I've got some stable coin, and I want to swap it for Ethereum. And so I go to Uniswap and I send in my USDC to the Uniswap smart contract, and I get out Ethereum on the other side at whatever ratio the exchange is going to give me for that point. Now that is an exchange transaction or a swap. And
presumably, as we begin to build more layers as well, would that cost increase as well? So you're starting to compose applications together, like your example earlier about Aave. Does that continue to increase the transaction cost?
Yes, and it's a really good point as well, because what happens is you get these very complicated transactions that are touching many applications all of the time, because they're arbitraging between all of these different markets. So like, why does Uniswap's price always track incredibly close to the price on Binance, right? So like the Ethereum price on Uniswap and the Ethereum price on Binance, like second to second, are almost exactly like aligned. How does that happen if the block time is 10 minutes on Uniswap? The reason it happens is because people are essentially intra-block time moving, like doing these like complex composed transactions between all of the different DeFi applications, borrowing from one place, trading, then repaying the loan, all in one transaction. All of these things are happening. And so those transactions are really expensive, again, because of the way that these public ledgers are architected, not to understand what assets are, not to understand what swaps are, not to understand how to deal with them. And so that's where you get this massive disparity between the things that people are using it for and what they benchmark, the performance they benchmark for, versus what people advertise. So transactions per second in Solana, 65,000 transactions per second. DEX swaps per second, 273, and that's just a simple DEX swap, one token for another. That's not a composite swap.
It's quite a difference there.
Right.
So let's move on then over to, so we've established then the current systems have some limitations that don't seem anywhere near sufficient to address the $400 trillion global financial system.
Yeah. Let me just say the last one, poor user experience. That is a critical one, right? The last thing is that the crypto user experience sucks. It sucks so badly that it kind of is laughable. And like when I've spoken to leading DeFi projects, some of them, and these are ones that got $1 billion under management, have a 95%, sorry, I'm repeating numbers here. I think it's like a 92% bounce rate on their website from someone going, I'm interested in that thing, to actually being able to deploy it in their application. And that's because the user experience of a new user coming into crypto is so difficult that people literally, when they come as willing buying customers, can't even get their money into the applications. And so that there's lots of reasons for that. But the user experience is also awful, and is a big limitation for everyday people from using crypto, full stop.
That's fair. MetaMask is not the easiest barrier of entry, especially if you're trying to get, say, your dad or your grandpa into it. It's not the most intuitive thing to explain.
Right.
So very curious then to unpack some of the solutions that Radix has to offer. There's it seems like you'll have a holistic solution tackling each of these problems we just addressed. So maybe we'll just start from the top and work down. So Cerberus, tell us a little bit about Cerberus and what makes it different from the consensus you might see on Bitcoin or Ethereum.
Yeah, so before I go layer by layer, I think the thing that I would like to sort of start with is, we realized pretty early that DeFi was going to be big. Like we took the decision to pivot to DeFi well before DeFi summer and all this kind of stuff. And and as a result of that, we took a very holistic view of going, right, if we're going to decentralize the global financial system, we're going to create a platform, public ledger platform, on which $400 trillion of assets and 3.5 billion people can use it. What do we actually need as properties at every layer of the stack that means that this can work for that? And it actually led us to down a bunch of decision points that made us realize the biggest one was assets, and like the concept of assets have to be native to every level. Like, so from consensus to execution to programming language to the user experience, like assets have to be core to the functionality of the public ledger. Because if you make that happen, then suddenly you can make much greater efficiency in how you do execution. You can make scalability work really well for these kind of applications. You can make the programming experience incredibly easy for developers, and you can make the user experience incredibly intuitive for the user. So that's what that's what we saw as necessary for the stack, and then we started to build each layer of the stack specifically with these use cases in mind. So Cerberus is a consensus algorithm. It's a peer-reviewed consensus algorithm that we worked with the University of California, Davis, on validating, which is a cross-shard consensus algorithm that allows linear scalability. Now, those are the cross-shard consensus doesn't matter so much as if you're wondering how to think about this, you can think about the difference between a single-threaded CPU and a multi-threaded CPU or a GPU. And that's essentially what the Cerberus consensus is about. It's about creating a data architecture that allows you to linearly scale whilst making sure that whilst essentially relying on the fact that you can have, or you can deterministically map transactions to the system. So what I mean by that is if I have a wallet and I send a transaction and I send 2 transactions from my own wallet and I map that wallet, let's say I map that wallet address to a shard in the ledger, both of those transactions are going to come from the same shard, which means that the nodes responsible for that shard can automatically go, we probably need to make sure that those aren't the same inputs and make sure that there's no conflict. And then we'll have to do some kind of consensus, ordered consensus on that. However, if I have 2 transactions that are emerging from completely different shards, so I have, let's say, Blake, you have your wallet mapped to another shard. Mm-hmm. There's no reason that we have to order those transactions against each other. We still have to run consensus on them, but we can have them in absolute parallel. And so what Radix has done uniquely is create deterministic mapping of transactions and operations across a huge sharded infrastructure, and then created a way of bringing together operations that are related and separating and able to run in parallel operations that are not related. And this, like from a database point of view, is relatively standard. Anyone here who's sort of works in anything to do with the sort of Google database architecture will be like, well, that's relatively obvious. But like anyone who knows Spanner, for example, will be like, oh, that sounds interesting and relatively familiar. But like the thing that we had to do, and the thing that we spent most of our time on consensus algorithms is how do you make sure that you can bring together many different shards in a massively sharded architecture to come simultaneously to consensus around a set of actions at the same time, whilst allow everything else to run in parallel. And there's a bunch of really clever stuff we had to do, but a part of that is the Cerberus consensus algorithm. And then part of that is actually what we call the transaction manifest. And the transaction manifest is what tells consensus what is connected and what isn't. And that goes all the way up to the user level, because the user is essentially able to say, this is what I want to do. I want to, stitch together Uniswap and Aave and SushiSwap. And then is able to submit that to the ledger, and consensus is able to go, okay, these 10 shards, these all need to be brought together for this consensus operation. And this is what's called atomic composability, this idea that you can stitch together many things and come to a simultaneous decision on them, whilst that is broken. That very important property is broken by every other sharding technique that I've seen out there, because it doesn't allow this simultaneous ability to run in parallel and to also run synchronous consensus operations across multiple shards running in parallel. So that's what Cerberus is. The outcome.
Could you maybe give an example real quickly of a type of use case where atomic composability would be important?
Yeah, sure. I mean, like they all come back to DeFi, right? Like, let's go back to Uniswap. let's say that I can see I'm a trader, and I can see that Ethereum is mispriced on Uniswap. So let's say that on Binance I can buy Ethereum for $1,000, but on Uniswap it's currently trading at $1,200. So it's trading $200 above what the market price is.
You've got an arbitrage opportunity.
Arbitrage opportunity, exactly. But let's say that right at this moment I don't have any Ethereum, because what I want to do is I want to sell Ethereum and get USDC, because I can sell Ethereum for more than it's worth on the market and get out USDC. So what I've actually got is, let's say, is USDC, right? Or let's say I've got something else. What I can do is I can take a loan from Aave. I can against some collateral that I have, because I don't want to do another trade to be able to do this trade. What I want to be able to do is borrow against the collateral I have. So let's say I've got some wrapped Bitcoin on Ethereum, right? So I can borrow against that wrapped Bitcoin, borrow my borrowed ETH, trade my borrowed ETH against Uniswap, get out my stable coin, and then pay back the loan. Now, anyone who's following this completely realizing that I'm paying back the loan in something other than Ethereum, let's ignore that for the second, because normally what the arbitrage trades is between two dexes, but it doesn't matter. Now, what you're doing is you are borrowing, trading, and repaying in a single transaction. You aren't waiting block time. You don't get the loan, wait for the confirmation 10 minutes, do the trade, wait for the confirmation 10 minutes, repay the loan, wait for the confirmation 10 minutes. You're not waiting 30 minutes. You are doing all of those actions in a single transaction. You're saying Aave, loan, Uniswap, trade, outcome, repay loan. And that is an atomically composable transaction, because you don't want the loan if the arbitrage trade disappears. And you don't want to do the arbitrage trade if you can't get the loan. In fact, you can't do it unless you have it. But on Ethereum, that works fine. On Ethereum 2.0 or layer 2 scaling, or Polkadot subnets, or Polkadot parachains, or Avalanche subnets, if those two applications, if Uniswap and Aave are on different chains, then you can no longer do that in a single transaction. And so the ability to arbitrage price within that 10-minute period of confirmation, you suddenly go from being able to trade to the second and get pricing perfect on all of these financial marketplaces that have been created on top of these platforms, to going back to having to wait multiple blocks for any single trade to go through. And what's more is you can't make it atomic, meaning that you have to do the loan first on one shard, wait until you got the loan, hope that your arbitrage opportunity hasn't disappeared in that time that it's taken you to get the loan, do the trade, and then go and repay the loan. And so all of the things I'm talking about here, this is the thing that's so deep and interesting about the space, is that the space works well while everything is on a single shard. But because it's on a single shard, it doesn't scale. And so the industry keeps hitting up against these upper limits of scalability. But then when they went, okay, well, we need to scale it, they only looked at transaction throughput, or like the idea that these smart contract applications were like on their own. You could go and put this one on one shard and that one on another, and it wouldn't matter. The thing is, it critically matters. 69% of transactions on Ethereum compose together 3 or more smart contracts. So 69% of all activity on Ethereum uses atomic composability, yet every single sharding technique, layer 2s, dank sharding, subnets, all of this stuff breaks this ability to be able to stitch everything together. And so we're going to break DeFi by all of the ways in which we're sharding. The reason that we're not seeing it break that much at the moment is because these new ledgers and these new systems haven't reached the next level of scale where this will then start to break down again. You'll see fragmentation of liquidity, and you'll see worse pricing between markets, and you'll see bad user experiences emerge as a result of this critical function being broken.
So would you say that it's potentially likely that the future is less of multi-chain and more of single chain, just due to the nature of being able to atomically transact between networks?
Yeah, so like I've had extensive debates on this. Where the efficiency of price discovery is important, the future is more likely to be single chain if that single chain can scale without breaking atomic composability, which is why we built Radix specifically for that. That was the laser focus of our consensus algorithm: linear scalability without breaking atomic composability. Then you have a high likelihood of the most efficient place where the best pricing is constantly, and therefore the best liquidity. That is likely to be the end state, where you don't need efficient market pricing to be discoverable. Then you can exist in multi-chain worlds. So like, here's a good example of where you might do that. If you have a game that's a massive, let's say it's Fortnite or something like that, but has also got a Web3 component where you can earn NFTs, or you can and you can buy and sell them and all this kind of stuff. Everything that you're doing within the game, your individual, the player to game interaction that only exists within the universe of the game, that can exist on another chain, that can exist on in another place. But the moment that you want the assets that emerge from the game to have an efficient marketplace, you're going to want to bridge those to wherever the most efficient marketplaces are. And the most efficient marketplaces are going to be the places where this ability to do atomic composability is going to be least affected. So I do believe in a multi-chain world. I just think that the specific financial aspects of it are likely to default to single chains because of the pricing efficiency of that.
So an exchange like NASDAQ would probably end up on a single chain as opposed to multi-chain, because you need that concentration of liquidity.
Right. And then you would have assets bridge in and bridge out depending on their utility. And so like I can see both happening. Right. I can see a world where one chain dominates because it's just easier to build and provide user experiences on a single unified platform than it is to constantly having to bridge between different ledgers. And there is going to constantly be that problem, right? Like, no matter how you cut it, like bridging between different universes of assets and different universes that have probably got slightly different standards or slightly different VMs or slightly different whatever, that's always going to be a friction point. And so it may be that everything ends up as a result of the gravity of value and liquidity moving to one. But I can also see arguments against that as well, where people want to be able to dial something up or down because their use case requires so much scale. But I don't know. Fair.
Well, taking it back to Radix here, let's talk about the Radix Engine v2 and Scripto a little bit.
Sure. So the Radix engine, well, the way we describe the Radix engine, you can think of the Radix engine like the easiest comparable is it's like a game engine, but for finance. So before game engines existed, like Unity and Unreal, developers had to spend a lot of their time building the things that made building a game possible in the first place. So if you wanted to build a game and there was no game engine, then you had to build a rendering engine, you had to build a physics engine, and you had to work out how you could implement your game for specific hardware. And you had to do a bunch of like actually very complicated low-level coding stuff. And so it was a relatively cottage industry because you had to be quite a deep expert in computer programming to be able to build a game, because you had to be able to work all the way up and down the stack. And so you get certain developers like John Carmack, or the guy who created Roller Coaster Tycoon, who built it all in assembly. Like, those guys saw the Matrix and they were able to build games, but most people couldn't. And so there was a lack of developers. what happened was the games engines came in and they went, okay, we're going to have general purpose rendering engines, general purpose physics engines. We'll do all of the hardware implementation so that everything renders down for, like, you can do distribution on multi-platform and all this kind of stuff. Don't worry about that. We got you. All you guys need to do is work out what you want your game to do. Like, what's the gameplay going to be? What's the world going to be like? What's the art going to be like? And as a result of that, gaming went from a cottage industry to bigger than music, TV, and film combined. Well, we've done the same thing with the Radix engine, but specifically for decentralized finance, Web3, and finance. We've gone, okay, there's a bunch of primitives that everyone is spending all of their time building in DeFi that just we know is necessary, or Web3 or whatever. We know these things are necessary. We can actually describe the universe of general purpose components that can be then personalized or customized for what is necessary, that gets rid of like 80 to 90% of the effort that people are spending on building these applications. And crucially, what you get as a result of the Radix engine is also a bunch of security for free as well. So like certain asset behaviors just aren't possible because of the way that the Radix engine has been built and actually baked into the underlying ledger. You get to leverage all of the underlying, all of the efficiency of using the rules engines of the ledger to like create things like, single issuance tokens or multi-issuance tokens, NFTs, like accounts, permissions, badges, authorizations, like all of these things that just like make up building these kind of Web3 and DeFi applications. They're just given to you as a result of the Radix engine. And that takes literally about 80% of the work away of building something like Uniswap or building something like Aave or building something like Bored Apes, right? Like suddenly that's just for free. It's just there. But that's an engine. It doesn't give you full expressibility. So that's where Scripto comes in. So Scripto is our programming language, which we spent about 2 years interviewing DeFi developers and Web3 developers to get feedback on how do they architect, how do they think about building. We started with like essentially pseudocode and documentation before we even built any virtual machines. We sat down with people and repeatedly iterated on going, does this feel good to build Uniswap? Does this feel good to build Aave? Like, do you understand these concepts, these primitives? And so the programming language we built it using Rust, which gave us a bunch of really cool features, like that we could make the compiler like be able to throw an error if you weren't handling assets correctly and things like that. So things that would just be caught before you could even compile. And so now you have a programming language that has a bunch of really cool features from Rust and is specifically designed for Web3 and DeFi that makes it super easy for people to get started, that we've tested for like 2 years on people to be like, is this good? Is it fun? Is it intuitive? Plus all of the like fundamental building blocks that the Radix engine give you to create like this development environment that we think is like the best hands down for building anything in crypto, Web3, and DeFi. And we see that from the feedback we get from developers. We've got we've gone from 0 to over 5,000 people building and learning Scripto and working with the Radix engine in like 12 months, which, I realize I'm talking to Google and people that you guys would be like 5,000 developers. Like we sneeze and find that, but like, yeah, like for
compared
crypto,
to your 20,000 in the total ecosystem of DeFi,
yes,
it's a sizable number.
It's a sizable number when you compare the immaturity of the space and how few people are actually building in the space at the moment. But like our view is, look, most of the big businesses that are going to be built on top of, most of the big startups and successes and unicorns are going to be built on top of Radix and public ledgers. The developers who are going to build them haven't even started coding in this space yet. So we don't care about compatibility with the current space. We don't care about Solidity compatibility or EVM compatibility. Instead, we care about giving the best possible tools for people to go from idea to production code, because the majority of people who are going to be innovating and creating this space haven't come in yet. And that's why we built Scripto in the way we did and the Radix engine in the way we did.
That's awesome. And I'll say I've actually tried out Scripto and was able to build a multi-asset lending platform in about 48 hours. Granted, POC, but it's pretty powerful. I'll vouch for my limited experience with it. But it's definitely interesting to see. Much different from what you'd see with Solidity or something like what Solana has to offer. So just
and
definitely.
And at the end of that, how did you feel? How confident, or like how confident did you feel like you could get on the security of what you built?
I guess as a developer, you want to believe that everything that you build on will just work right out of the box. So
Right.
the feeling is that it's secure, but I guess it's one of those things where you have to test it out in the wild.
Tested,
Yeah.
For sure. Yeah, and like the that's one of the other things is like sometimes confidence can be a double-edged sword, right? Like, but I've seen developers try building stuff with Solidity and then deciding not to deploy just because they're kind of terrified about the idea that it might not be secure, even if you've done all of these tests and all this kind of stuff. And what we're hoping we can get to with track record is people getting more and more trust in how, when you build with Scripto and the Radix engine, it is actually just a lot harder to make the kind of stupid mistakes that is unbelievably easy to make in things like Solidity, and therefore less terrifying when you actually come to pull the trigger and deploy something on a public ledger and put some assets into it.
Once you start having $400 trillion in assets on your program.
Right. And like, to be clear, we're not saying that you can't get you can't build in a way that will mean you get hacked and exploited. You can't do something stupid. Of course you can. It's just a lot harder to do something stupid.
But we have one more bullet here before we move over to Q&A. For UX interfaces, what are y'all bringing to the table in terms of improving upon the poor current state of UX for DeFi?
Yeah, so we're doing a big event tomorrow called RadFi, where we're going to be which goes live at 1 p.m. Eastern tomorrow, and that's going to be showing a lot in what we think is sort of necessary for this. But the underlying message is this: look, the two big problems in the UX of crypto is, one, securing your crypto in a non-custodial way is basically utterly terrifying. So if anyone who's had to deal with seed phrases and the concept of backing up their keys, or using these like devices like the ledger or whatever, that's actually really off-putting for everyday people. It's really difficult to get people to get comfortable with that. If you're like a security geek or something like that, it feels really great. You're like, oh, cool, like I understand all of this stuff. But most people, they're like, I don't understand any of this. I had to do 20 steps just to be able to hold assets, right? And if I lose it, it's gone. If I lose this piece of paper, it's gone. Lose this little device, it's gone. So what Radix did is we went, okay, we need to have accounts. We need to break this concept that your public key is your address, and instead go, well, an account, which is a smart contract, is your address. There is no such thing as public key being an address. And your public-private key pair is just a authorization on that account, which means that you can add multiple keys with different rules associated with that account. Like, that's a really complicated way of saying, on Radix, you can do account recovery, you can do account backup, you can make multiple devices be authorized for the same thing. You can have two-factor in a decentralized way. So you can literally use an YubiKey as your second signing factor along with your mobile phone. But the upshot of that is you can have accounts where you create the account, you link your mobile phone, you link your computer, you lose your mobile phone, no problem. You give your recovery key. You say, oh, my wife can be my recovery factor on my account with her phone. And now if my computer and my phone get stolen, I can still recover. She can't spend because that's the rules, but she can help you recover. So this ability to make it feel just like a normal application where you can go, oh, if I've lost my device, it doesn't mean that I've actually lost access to my funds. I have all of these ways that we can create user experiences. And obviously there's user flow that has to go into that, but user experiences that actually go from being absolutely terrifying, this one piece of paper is it, and if you lose it, then all of your money is gone, to being like relatively much easier to deal with. And then the other part of this is people don't understand what they're signing. So when you go into MetaMask and you go and do a transaction with a smart contract, what MetaMask asks you to sign is a hash, but it doesn't say anything else. It just goes, sign this hash and you're going to be, and it'll cost you this much ETH, but it won't even actually tell you whether or not you're sending some stable coin or what you're doing, which app you're interacting with or anything like that. You're just signing blind. You click sign, you wait for like 10 minutes, and it's kind of terrifying and gut wrenching. And at the end of it, maybe you've done the interaction you wanted to, maybe you haven't. Again, if you're in crypto, that's fine. Everyone's used to it. But if you're not in crypto, it's terrifying because you have no idea if you've just lost all your money. And what Radix does with native assets and the transaction manifest means that in the wallet, everything is now become human readable. They'll go, okay, you are about to send these assets to this application. You're going to do these things. You're going to expect back this within this range. Do you want to, and you're going to pay this fee. Do you want to do that? Yes or no? And it goes from being like online shopping without a checkout cart to online shopping with a checkout cart. And the difference from a user experience is just night and day in terms of how easy and usable it is. And again, all of this is about making these ledgers and public networks human friendly. And I think that's the last bit that is necessary to actually bring DeFi Web3 mainstream.
That is very intriguing. Anything to bring confidence to whenever you hit that send button is absolutely necessary. Did you want to talk a little bit about RadFi before we conclude here? Just one more opportunity for a call
so
out.
like we have spent a year and a half working on something that we are showing for the first time tomorrow. And that's what RadFi is. And we think it's pretty cool. And I'm not going to say any more, but like it's happening at 1 p.m. tomorrow. It's going to be a live stream. It's going to be on our website. You just go to radixdlt.com/radfi. And then from there, you'll get to see at the same time that everyone else does some of the stuff that we've been working on for a very long time. And I think that the other thing that RadFi will do is bring together all of these concepts in a unified whole and give you a bit more of a holistic sense of all the things that Radix is doing. So please do sign up for that and watch it when you have time.
Fantastic. Well, thank you very much for joining us today, Piers. It's been an absolute pleasure.
Blake, fantastic. Thank you so much. And Caitlin, thank you to you too.